Thank you for joining us in another tutorial video. This video is for people that are studying the Level 3 Digital Marketer Apprenticeship Standard, and this is a tutorial that I had with one of our apprentices, and I decided to record it for revision purposes. If you're interested in myself or our company, please head over to brooksandkirk.co.uk where you can find out a bit more about us. And please like, comment and subscribe if you find this content useful or informative or entertaining at all. Let's get on to the content. So this lesson is all about protocols and file types. So if we just go back of what we covered last lesson, network layers. Could you summarize some of the early layers, like the physical layers and stuff like that? What do you take from the last lesson?
So it also doesn't help that there is prompts literally right next to them, but
That's okay. Elaborate.
The physical layer is the hardware layer. So this is the cables, this is the actual components. So it's graphics card, it could be processor.
Not the graphics card, not processor, I'm afraid.
Does it knock out?
No, they're nothing to do with the network per se. Yes, they're computer components, but they're not network components. Cables, tick, definitely. You could also argue that the wireless, the Wi-Fi, actual radio frequencies is the physical component because it's physical radio frequencies, obviously, for sure. What about the next level up the layer?
So data link, which is the MAC address. Though the MAC address can differ depending on if it's on a Mac, Linux, or Windows. If I remember correctly, and Cisco, how they present it.
Yeah, if you're buying a device from a specific manufacturer, they will have like a bank of MAC addresses. It's not operating system driven. It's just the manufacturer driven. So every network device has to have a MAC address. Could you give me some examples of network devices?
Network devices.
Mm-hmm.
So are you referring to the one on the back of the PC? Or I don't know.
Yes, that's one of them. Yeah.
Are you referring to the one that converts digital signal into optical, which is like SFP?
Good. Yeah. All of these have got MAC addresses. What about more portable devices or stuff that might be in a comms cabinet, a server cabinet, or even in your home?
Do you mean? Oh, okay. So you mean servers? Servers, switches.
Good. Yeah. Excellent.
Okay.
Yeah. So just to summarize the next levels moving down then. So from there, you will have a device called a router that will then assign IP addresses to these devices that want to be on the network. So it's a device will go, hey, DHCP server, can I have this is my MAC address, can I have a IP address please so I can communicate with other stuff? And then the DHCP within the router will assign that specific MAC address an IP address, and that's part of the ARP table that then gets stored in it's like a database, so that the router then knows if IP address A wants to speak to IP address B, it knows physically what MAC address that lives on for that moment in time. The MAC address never changes, but IP addresses can. Okay? Because there's only a limited number of IP addresses in the space. So, transport layer of the network layers is how these packets will get transported across networks, mostly looking at UDP and TCP. Have you ever come across UDP or TCP?
Yes, but it's only since we've been really talking about it.
That's okay. It's okay. So there are two differences. Can you remember the differences between the two?
Yeah. So TCP is the more secure. It checks. UDP is literally just throws the data out, doesn't care if it gets there or not.
Perfect. Yeah, I couldn't have said it better myself. Exactly that. TCP will have a handshake component, and From there, you've got like the ports. This TCP or UDP connection will be broken down into thousands of different subports, so that the information doesn't clash all the time. It's always keeping into the same sort of protocol. So if it starts communicating on port 80, one device will always start communicating on port 80 to stop other things from clashing or getting confused with each other. So it makes sure it then goes down to the relevant layer. Now, what we're focusing on in this lesson is kind of these layers. We've done the others, okay, so we're going to focus on the next layers of it. So main learning objectives for this session is to understand and define protocols that are used in web communication. We need to evaluate specific file types that you as a digital marketer are going to encounter throughout your role. Yeah, specifically looking at the file types. So is there a way you can tell, just to check your previous knowledge on this, how can you tell what file type something is in Windows?
The dot, whatever the end is.
Yeah, exactly. So there's a file extension after the dot, and it'll kind of tell us. And certain extensions have pros and cons. So you at some point need to evaluate the strengths and limitations of specific file types. So to achieve this, the outcomes are that you're going to be defining specific document, image, audio, and video file types. You need to be quite proficient at these file types because some of them can be quite complicated. Evaluate those file types within the categories that they live. So you're going to be able to analyze the strengths and limitations of them. Going to look at and explain. You're going to need to explain what compression is, how and why it's used in specific applications. We're not going to compress something all the time, or you might over compress it and therefore make it useless or whatever. So we're going to look at compression. And then look at how compression affects the actual perceived quality of the object, its file size, compatibility with other systems and its intended purpose and use case. And obviously it affects digital and web because it affects the load times. Why are load times important, do you think?
Get bored so easily. You either want something to snap and you want something that works. If they have to wait, they're going to click off.
Exactly. Yeah. If it's something that takes, so you have to be able to cater for so many different possibilities. Yeah. So, okay, right. We're going to look at now the items that are within the presentation stack of the network block, network packet. So, hypertext transfer protocol. You'll often... What software works with hypertext transfer protocol?
Software, do you mean like Chrome? Are you talking like
yes,
Chrome?
Chrome's...
So that means Firefox, Edge.
Do you know what this one is?
Chromium.
Yeah. What's the relationship? Do you know?
Between the two, because wasn't Edge based off Chromium?
It is, yeah. Ironic, isn't it? How Microsoft thought, oh yeah, we're going to stick with Internet Explorer, but actually, yeah, now we think about it, let's kind of stick with Chromium, which is Google's open source web authoring package, or not web authoring package, web browser platform. Yeah. So, web browsers will communicate through this. You can see within the URL of the address bar that you tend to be using HTTPS these days. But inside of that, you also have the core HTML files. Do you know what HTML file is?
No, I don't know what HTML file is. Okay,
so HTML stands for Hypertext Markup Language, and it's basically a programming language in text form that if a server gives it to a web browser, it will it'll be presented with a series of instructions of what to display on screen and how. Okay.
Okay.
So all websites start off with some HTML text, HTML instructions. Now, embedded inside of HTML and often used in web technologies is JavaScript. Have you heard of this before?
I have heard of JavaScript, yeah.
Do you know what it's all about?
No, because I never used it before.
Okay, it's client-side processing. What do I mean by client-side?
So, client is the person who's making a request.
Mhm.
So, if I'm making a request for a web page, my device that I'm using it on is the client.
Yeah, exactly. So JavaScript is a programming language that you embed in a website, which allows you to perform more advanced functions on a web page. So you could have like drop-down menus, accordions, all sorts of stuff. You can do that using a JavaScript code. Games sometimes, interactive objects or elements. CSS, cascading style sheets. You'll look at this a lot more. Have you come across these?
No, I've heard of CSS, but I've never used it. I don't know what PHP is or
Okay.
SQL.
Fair enough. Cascading style sheets, it allows you to create a style, you link it to the HTML file, and then that style will be called every time. So let's say all of your body text, you always want it to appear a certain font, a certain size, certain padding. Then you can create a style sheet which sets those parameters, so you only have to call the sheet and the actual style as opposed to constantly program the HTML parameters. So it's kind of like a global lookup style. It's a style. I don't know how else to explain it. Does that make sense?
Yeah, so it's just a guide that you don't have to code everything up over by hand. You just say, oh, look, I know how this is supposed to be done. And it does it.
Exactly. Yeah. So it's like a recipe of what your site should look like embedded in one file, and then that file's linked to your HTML file so that when it's called, it knows how to apply all the fonts at the same. So you only have to call that one style and not necessarily say font size 12, font size Times New Roman, font weight. You don't have to do that every time you do a new line of code or whatever. PHP is server-side. Allows you to communicate server-side. So often PHP is used to interact with a database. So databases are critical in a modern web page, such as MySQL server is a database application. MariaDB is a database application, and basically you can store. So let's think of a shop. In your database, you would have the products, the price, cookies that tells the client how much it costs in their basket, all of that sort of stuff, so that it can be a dynamic page. It isn't static, and it's calling stuff from a database. You know, your image directories, your image permissions, users, if you need login details or whatever. It's all managed with PHP and communicating with an SQL. So that it communicates using an SQL programming language to the database on the server. So all of this is managed by inside of the HTML content. It's all called upon within that area, if that makes sense. Okay. So that's your web browser, pretty powerful. HTTPS, exactly the same stuff that it'll do, but it'll use a different port 443 instead of port 80, and the communication between the server and the client is secured with encryption. Often it's encrypted with secure socket layers, SSLs, or transport layer security, TLSs. You'll often see you'll see certificates in the web browser as the padlock icon. That inside will be a certificate which confirms that the server is genuine and not trying to intercept the traffic or the data. Pretty much all web pages now use HTTPS, even static ones. I think Google penalise it as part of their search engine optimization. So that's kind of what what that's all about. Now, other web communication protocols that the awarding body want you to know about: FTP, File Transfer Protocol. It allows you to use applications or act like your file manager. So you can transfer files from your web server to your client server relatively easily. It's not the world's fastest. It's bound by your internet connection, of course. It's not even encrypted. There is a secure variant of it, but it's a pain to configure. So you just have to be aware, if you're using FTP ever, it's not encrypted unless it's FTPS. Then it would be. And it operates on port 21 usually, and it allows your client to access a file server to put all your HTML files, your images, whatever it may be, on the web server for it to then serve out to other clients. So it tends to be the way that you communicate with your file server. Okay? Another one that the awarding body want you to know about, although I don't understand how it has any relevance to a digital marketer, but VoIP, Voice over Internet Protocol. Here's a little buzzword for you: ubiquitous.
Okay.
What's that mean? Any ideas?
I have no idea.
That's a literacy link for the day. Ubiquitous is everywhere but nowhere, if that makes sense. So it's a service that can be accessed on the internet. People associate the cloud as a ubiquitous service because it's kind of everywhere, and you can access it everywhere. And VoIP allows for phone calls to be done via the internet, as opposed to the old system of actually physically having a POTS. That's an acronym. POTS stands for Plain Old Telephone Service. No beating around the bush. And it allows you to connect to PSTNs, which is plain standard telephone networks. So literally your BT point. So yeah, VoIP uses that, and it uses something called a SIP trunk to connect a internet-based system to POTS or PSTNs using a protocol called SIP. It's SIP basically is the handshake. It says, "Hey, I'm a phone. I want to make a call," and it'll go, "Hey, SIP trunk, can you dial this mobile number? Here's a handshake," and it go, "Yeah, sure, dialing," and then it says, "Right, I'm done with you. Here's the audio of the phone call. I'll leave you guys to it." That's pretty much what SIP does. It's the handshake process. And then if we look back at the transmission layer, which part of the VoIP session would be TCP, do you think?
I would say it's a TCP.
Mm-hmm.
I think the actual phone call itself is a UDP.
Yes,
but
you're absolutely right.
The initial part would be confirming it, making sure it's confirmed, and then connecting.
Yeah. Why is UDP the phone call?
Because they know they're connected. They just need to get the information from one place to another very quickly.
Exactly. Yeah, you can't have lag or latency in a phone call. So video streams and phone calls will usually be done via UDP. Yeah, bang on. So file types. Let's move on to file types now. This is where the awarding body kind of made some mistakes, actually. Because yes, they want you to know about docx, text files, PDFs, ODTs as another one. It's coming more and more common. Have you seen this company logo before?
It's like a Mac logo, so no.
It's OpenOffice. It's a free version of Office that's open source. And from Office 2019 onwards, it asks you whether you want ODT to be the preferred format. Doc and docx is a Microsoft Word document.
Yeah.
And essentially, all a Word document is a series of instructions packaged in a file that then the client could then interpret those instructions as it best sees fit to make it look like what the author of that document wanted it to look like. There are problems though, because it's only instructions, those instructions can be interpreted slightly differently. So if you've got font styles, say you're using a quite an ornate, I don't know, a Coca-Cola font that you've downloaded or whatever, it'll only include the text and not the fonts.
Right.
And you know as well as I do that you can have different versions of Word work properly, or the tables will just go all squiffy and you can't read it or whatever. TXT files, do you know any strengths or limitations of those?
I mean, it's certainly not as versatile as a document. It's just straight text.
Yeah, and that in its own right is its benefit, because it is just text, nothing else, so therefore it wouldn't really need to be encoded any differently, because it's just literally, yeah. So often you might get blocks of code that are sent to you in a text file, because you can just dump it into your whatever system you're using and not worry about whether there's a picture inside of it as well that then skews up your formatting or whatever. PDF, what's that stand for? Do you know?
I actually don't know what PDF stands for.
Portable document format. It's supposed to be, yeah, it does contain fonts as well.
Yeah, you can.
Can you talk to me about some strengths or limitations of PDF?
Okay. Well, you can put links in it for starters, which is nice.
Yeah.
Although to be fair, you can do that already with a document as well.
Yeah.
It's mainly because whatever you produce in a PDF, someone else can look at that and it'll be the exact same. As far as I'm aware, there shouldn't be any difference.
What about limitations?
Limitations. Well, it's open source since Adobe gave it up, so that is a limitation.
Is it? Is that a limitation? That's interesting. Why is
Well,
that a problem?
I don't know, because considering it's open source, I feel like that's more of a benefit. Sure, Adobe
It is.
charge an extortionate price to use their editing software for it, but I mean that could be a negative, but that's not really. I mean, as long as
I
you can
think
get
that's
the
them
PDF.
being clever. If you make it open source, it allows then other third-party developers to fork if they want to and make a slight different version or improve it without them having the administrative costs of doing so. And it also cements it as the standard. If Microsoft Word and OpenOffice is able to export as PDF, it makes it the standard. If you had to pay to do that, then it wouldn't. So
I'd agree with that.
That's another benefit. Any other limitations that you can think of? It could be a better strength or a limitation, to be fair.
No, I can't think of anything.
They're very difficult to edit. So, from a security and compliance point of view, it's pretty good, because you can send, say, a brochure via PDF, and they couldn't just change the price and say, hey, you told me the price was £400. Here, look at this PDF you sent me. Because they wouldn't have been able to edit it, really. So it allows.
You can check in metadata.
Yeah, you can. Exactly, and it kind of stores all of that within the actual file. So it's often used for security purposes, contracts and things like that, because it's not so easy to manipulate and get away with it. You mentioned the main point is it can be quite small. It's easy to transmit. It'll look like how you intended it to look on the client's computer.
Right.
Next, ODT. It's like a Word document, just an open source version of it, pretty much. Now, interestingly, the awarding body included CSS and an XLS file as a document, but obviously they clearly don't understand what that is, because a CSS is not a document, it's a programming language that controls what the web pages look like. It's not a document. You wouldn't open a CSS file and go, ooh, this is an interesting read. And likewise with an XLS. What's an XLS?
I don't know.
Spreadsheet. Excel spreadsheet.
Oh.
It's not a document, it's a spreadsheet. Anyway,
Hmm.
yeah, just be aware that if that appears on the exam, they probably are wrong, but, well, they are wrong, but we might have to
fudge it.
might just have to educate them, but just give them the answers that they want.
Okay.
Images. There are two types of image files in the grand scheme of things. You've got rasterized bitmaps and you have vectors.
Yep.
Have you heard these phrases before?
I haven't heard of bitmap, but because I have heard of rasterization. I've heard of vector.
What do you know? What could you explain what rasterization is?
It's pixels, as far as I'm aware. It's just to do with how they handle and render pixels.
Yeah, exactly. So a bitmap is a map where all of these pixels live, essentially. So it's a 2D grid, and inside of this picture file is the code for every single coloured pixel, and it's mapped as a bitmap. And it's rasterized. A vector. What's the difference?
A point. It's like a point on a circle or something. It's like it's a tiny little dot that's a point, but it doesn't have. It's really difficult to explain a vector. But
it's basically a series of geometric instructions. It'll say, point A is spherical with a circumference of. So it's a list of instructions that then can be interpreted by the picture software. And there are significant benefits of giving instructions, because if you increase its size, it won't degrade quality.
Mm-hmm.
And they're quite small in file size, but the limitations of vectors are that you can't have detail. It's absolutely hopeless for photographs. You can't have photographs as vector files. Yeah. It's symbols, diagrams, that sort of stuff. So JPG, probably the most versatile, well, not versatile, it's the most popular way of storing bitmaps, rastered files. TIFFs tend to be higher in quality, often used for really large images. A PNG, you can actually have alpha layers in PNGs. So really good.
Alpha layer.
An alpha layer is a transparency layer. So instead of a bitmap having a complete square and then hard coding the white, you can actually give an alpha layer which is completely transparent. So really useful if you're chucking it on a website or something.
Yeah.
They're not that colour accurate. They don't have that many colours to deal with. So yet again, it's kind of going to be used for your logos and stuff like that, or basic images. A GIF, again, very limited colour space to deal with, but it can be animated, but that's very 1990s, and you'd never do that these days, really. RAW. Have you ever used RAW files?
I have used them once, and I'll never use them again.
Why?
Because they're so large. They take up so much space, and they take so long to load as well, which is a nightmare.
Well, maybe that says more about your PC than it does the file.
That wasn't my PC. I was using a Mac at the time.
Well,
that does explain a good chunk of it, granted.
Yeah, they are uncompressed. The benefit of them being uncompressed is you can change like the exposure levels and things like that if it's been captured in the raw file, and it won't degrade the quality. If you save it, well, you can't. It won't save, if that makes sense. You just can augment the parameters in real time, and they're all stored within the file. Yes, they are very large. There's no processing applied. It's straight from the camera sensor, often. and you would then make your JPEGs from that potentially, so that you know you've got the best color that you want, or whatever parameter you're trying to pick out. Yeah, large, RAM intensive, but on a decent modern workstation, it's really not a problem.
Yeah, they're not a problem.
Now, compression of images can be done in a variety of ways.
Yes.
So, compression is purely just to make the file size smaller. You've got lossy compression, which will physically destroy the artifact, and it will remove that data, and you can't get it back at all. This will be something in your exam, so remember lossy. Okay. Do you know the opposite to lossy?
Matte?
Close, not quite. It's lossless. So an example of how you could apply lossy compression, or a technique that an algorithm might do, it says, right, if there was 4 square pixels, we'll take an educated guess of those 4 and make it into 1 pixel that best represents those 4 pixels. You might kind of be able to see that on that visual example. Lossless, it basically just removes the non-essential information. It doesn't destroy the actual original artifact in the traditional sense. It would just remove pointless or irrelevant information from that file in the first place, or it could process it in a slightly different way. So if in your bitmap the very first top row of pixels were all white, instead of storing 100 lots of white pixels, which would take 50 bytes or 100 bytes of data, it could just say, well, just take the top row, please, and make them all white, and then kind of store that, and it will just interpret it, kind of almost vectorizing it to a certain extent. But yeah, that's kind of what that means. You can kind of remove the stuff that it doesn't technically need. So this image is obviously it's tiny, but it kind of makes sense how a bitmap would work. So you literally, I don't know how many across it is, let's say it's 20 pixels across by 20 down, and that bitmap would just contain 20 bytes of data. Each bit would be a byte, each pixel would be a byte, because it's storing 256 colors. So 256 in binary is 1 byte, isn't it? So that's kind of how that would do that. Another way of compressing it would be to reduce the color space. Obviously, this is a really extreme example just to demonstrate the purpose. You'd never want to deploy a 16 color image, but that was the 90s. You used to just get graphics cards that could do 256 colors, and that was it. Or you can change the resolution, actually the dimensions of the file. That will significantly reduce the file size. Alright, let's move on to audio, shall we? So, again, you've got lossy type files, what was lossy again?
Lossy?
Yeah.
It's the one where it takes similar, compress it into one. So for the colors, let's say it was in a little space of dark green, slightly darker green, light green, whatever. It will take the average of those 4, put them together, and pop out whichever the average of is for green.
Yeah, it would physically remove that and destroy it, and so you can't get that again back to how it was. An MP3 is an example of a lossy file format because you can't uncompress it. You can't make it its original quality. And one good way of explaining how MP3 works is, if you think the human hearing range is 20 hertz to 20 kilohertz, what an MP3 could do is remove anything above 20 kilohertz and remove everything below 20 hertz, because it physically can't be heard, so you could just get rid of it. And then they can also change the frequency and various other things. So MP3s, you can really only go up to 44.1 kilohertz sample rate and 16 bits of depth. And let me explain what that is. I'll explain what that is in another slide, but that's CD quality. So the maximum it can really go to is CD quality. AAC is again, it was kind of an iTunes thing in the early 2000s, but often used in film and cinema now, because you can have more than 2 channels, more than stereo. You could have 5.1 AAC files and things like that. WAV, or wave files, are very versatile, not really compressed that much at all, compatible with very low processing time. It doesn't need any processing applied to it. So that's why the very early CD players were just WAV files, because it could just spit those audio files out really quick to sound. You can go as up a really high sample rate, so really good quality, and high bit rate, so you've got the variety of volumes, so you can have lots of high volume and short volume and still be able to tell the difference. That's what bit rate helps you with. And as low as, really low quality, 8 kilohertz 8-bit, which is your kind of phone call sort of quality. And SIP phones tend to use really low WAV files just because it's quick to process. Lossless, you've got FLAC. It's the most common. It's slightly smaller than a WAV, but it won't reduce the quality. It's high quality in comparison to MP3, but not many devices can process a FLAC file. So you wouldn't really use this in web stuff, because only the top end stuff can kind of deal with FLACs. So let's break down sample rate and bit rate. So if you think you've got an audio file, an audio wave, a sound, what the computer will try and do is it will take little sample points of this wave and store these as numbers. You with me?
Okay.
So it'll take this blue natural wave and kind of try to make a digital representation of it. But because it's digital, it's only got 1 and 0 to deal with.
Yeah.
So it'll kind of square it out a little bit. So this is an example of a really low quality file. If it had more samples per second, then it could get more closer to the original file, the original wave.
Okay.
Now, bit depth is how deep it can go. So if you only had 1 bit depth, it would literally be an on or an off, and it would just be really square and it'd just be horrendous. I'll show you what it sounds like shortly. But if you've got a higher bit depth, you can have much quieter waves still represented well, and really loud peaks of the wave working, if that makes sense.
Okay.
So the higher the sampling rate, the more samples, digital samples, are taken per second. That's why it's measured in hertz. So that's doing 384,000. That should be hertz, not kilohertz, I think. Or it might even be another 3 zeros after that. That many times per second, there is a bit of data saved. Amazing, really. Yeah. That's it. So let's just quickly tab out, and so I've got an audio file loaded into Audacity. So that's what this audio file looks like as a visual representation. So the computer has taken the WAV file and converted it. It's not actually that loud, is it? Let me just quickly normalize it, because we've got all of this bit depth to work with, but it's only up to here. So let me just normalize it. There we go. So we've got 2 channels. Why do you think you might have 2 channels? 2 streams?
Better depth audio.
Not quite.
No?
This is a stereo file, so you've got one for your left ear, one for your right ear. Can you hear that now?
Yeah, I can.
Okay, cool. So can you hear this is a stereo file? You've got one left ear doing one thing different to the right ear. So if you actually zoom in, you can actually see the samples. These little dots.
Okay.
And it's so fast. Okay. Now I've got an effect here that kind of emulates what reducing the number of bits would sound like and what the sample rate would sound like. So if it's only doing 1,000 samples per second, you won't get the quality. And then if you do reduce the bits, you won't be able to represent volume very well. Can you see it's just static up here?
Yeah.
There's no volume, and that's getting close to your 1 or your 0. Just literally noise at that point. So yeah, that's 16 bits, so it's got the headroom to be able to represent the volume, and then the bit rate will just make it sound awful.
So this is what they mean by 8-bit. They have 8-bit music.
No, that would be 8-bit. No, 8-bit music is actually where the actual synthesizer used only works on 8 bits, so that's why you'll find it doesn't deal with volume at all. It's just kind of very digital stuff. So it's to do with the synthesizer as opposed to the audio format. But yeah, so you can visually see the samples. Does that make sense?
Yeah, that makes sense.
Right. You still see me okay?
I can.
Cool. Phone decides to ring, which is awesome. Now, video files. Oh, they're an absolute nightmare. You have encapsulation formats. Now, just because you see it as an MP4 doesn't mean that that's all the information in that file. Okay. It basically is just a package at this stage. And inside of that MP4, that AVI, that MKV, you'd have a video stream and you would have an audio stream with it. So like this example here, you can see that the actual video track is something called a H.264 codec.
I can't see that because of the quality.
Okay. It is a really small file.
Make it. Yeah. I can roughly make it out.
Yeah, it's a really small screenshot there. But on the tracks, it says H.264, 30 frames per second. Do you know what FPS is, frames per second?
It's just like, think of it like a camera. You take a picture of something, and then you take 30 pictures in a second.
Exactly. So one way of reducing the file size is to reduce the number of pictures in a second. It would just look garbage. Or it would look really stuttered, but it might be okay for like a short graphic.
Yeah, like an animation or something.
Exactly. AAC is the audio stream that's in there. So yeah, it contains a video stream and an audio stream. The sorts of video codecs that you probably come across is like H.264. H.265 is a more modern string to this. DivX, Xvid are more sophisticated algorithms that will reduce the file size quite a lot. But you do have to have specialist software to be able to interpret these. So you wouldn't use these inside of a web format, really. Software Handbrake is an example of what you're looking at here. It's a completely open source converter and it allows you to transpose between different file formats and things like that.
Right.
It's really computer intensive and requires a lot of processing power, obviously, because it will take every single frame and convert it. Take ages. MP4 is probably your most versatile for web stuff because what it does, it contains something called a keyframe, and it will update the video content in a keyframe so that it doesn't bombard it all the time with updates to the picture. So let's say you've got a black scene. It's going to be black for 3 seconds. So the keyframe will say, pixel A is black for 3 seconds. Don't bother me about this for the next 3 seconds. If that makes sense. Does that make sense?
Yeah, that makes sense. Makes total sense.
Okay, so it's more instructional based codec within H.264 that will allow for a smaller file type but not impact on the quality that much.
Okay.
And it allows for, the keyframes will be much shorter. Have you ever come across where you watch a video online where it just goes green and random pixels start appearing?
Yeah, I've seen that before.
That's when the keyframe hasn't been sent in time. So it doesn't know what the previous pixel should have looked like, so it'll just chuck it as green.
Right, okay.
Yeah. So factors that impact the quality. Changing the frame rate will obviously make it smoother or more stuttery. Compression, how the algorithm process it. So H.264 is one of the most common these days.
Yeah.
It is slightly larger than DivX, but DivX is proprietary software that you'd have to download separately. So a web browser wouldn't be able to deal with that. Bitrate, the higher the bitrate, essentially, the larger the color range it can deal with. It will increase the quality, increase the pixel size, decrease the pixel size, sorry, but it would result in a much larger file size. And then the keyframe length is the more keyframes, the less artifacts, smoother streaming, larger file size.
Okay.
Keyframes isn't actually in the awarding body content, but it is still really relevant.
Still useful to know.
Yeah. Resolution, the dimensions of the file, 16 by if you're going 1920 by 1080, then that's going to be a quarter of the size of 4K, and there's no point going 1080 on a mobile phone because it's probably absolutely microscopic anyway.
I thought 1080p wasn't a 1/4 of. It's slightly off, isn't it?
No, it's a quarter. Yeah. There's 4 1080p streams in a 4K stream. If you think of it as like a tile.
Yeah, no, I always thought that it was the actual resolution of 4K was actually slightly more than 4 1080p's.
Well, 1080 is binary. It transposes really well nearly to binary. So 4K it'll be 4 times that number. That's your numeracy link for the day. I can't work that out. Right, so just to wrap things up, because I know you've got to go in a few minutes.
Mm-hmm.
The larger the file type, then obviously the longer it's going to take to load. So you just got to bear that in mind when you're thinking of what the intended audience of that file is. You need to think of what's okay, what's good enough, because if you're printing it out, it's going to be different for it being read on screen. What's the purpose of the content? Mm-hmm. Will the viewer be able to access it? If your objective is to be as inclusive as possible and to hit as many audiences as possible, you need it in a file format that everybody can read, and they don't need to download PDF Viewer 994 or whatever. It's not so much a problem these days because PDF viewers are embedded in web browsers nowadays, but they didn't used to be.
Nope.
And that's it.
That's it?
Yeah.
Oh, sweet.
Have you got any questions?
No, not at all, really. Like I said, some of it I need to go over, but it's all pretty straightforward, to be honest.
Awesome. Speak soon then.